For centuries, the limit of human destructive power was defined by chemistry. When you ignite conventional explosives, like dynamite or TNT, you are rearranging the outermost layer of atoms, breaking and forming electron bonds. That chemical reaction yields a predictable, finite amount of energy. It releases roughly 1 electron volt of energy per atomic bond. To increase that yield, you have to bypass those outer electrons entirely and access the dense, vibrating core of the atom. Splitting a single atomic nucleus releases about 1 million electron volts per nucleon. In a single physical step, the energy density increases by a factor of 1 million. Accessing the nucleus changed our relationship with the physical world. We moved from simply rearranging atoms to dismantling them, accessing the fundamental forces of the universe. A normal landscape can be entirely erased in a fraction of a second. The transition from silence to total destruction happens faster than the human eye can process. Heavy radioactive isotopes like uranium-235 and plutonium-239 are unstable by nature. Their atoms are so large that they naturally decay, their nuclei constantly threatening to fly apart. Inside the casing of a falling thermonuclear weapon, time effectively stops just before the sequence begins. Releasing atomic power is a complex mechanical challenge. You cannot simply light a fuse to start a nuclear reaction. You must take a solid metal sphere and perfectly, uniformly compress it down to a fraction of its original size. Before any subatomic physics can take place, a nuclear explosion requires a carefully orchestrated act of intense mechanical violence. In the weapon's primary stage, a heavy core of plutonium is surrounded by a shell of conventional chemical explosives. When these lenses detonate, they do not blast outward, they direct a focused shockwave inward. That converging blast wave violently squeezes the plutonium core. By forcing the atoms closer together, the metal reaches a dense state known as supercriticality. At the absolute center of this collapsing core, the pressure crushes a neutron initiator. This device injects the very first free neutrons into the dense plutonium mass at the precise moment of maximum compression. This mechanical crush provides the necessary trigger. In less than a millionth of a second, the weapon transitions from conventional chemistry to subatomic physics. On the subatomic scale, one of those free neutrons strikes a single, unstable plutonium-239 nucleus. The impact causes the heavy nucleus to vibrate and snap apart. This process, nuclear fission, releases a sudden burst of energy along with 2 or 3 new free neutrons. Those newly freed neutrons strike adjacent nuclei, causing them to split in turn. This reaction cascades across the dense mass, multiplying exponentially in a fraction of a microsecond. This fission chain reaction releases the energy equivalent of the bombs used in World War II. In a modern weapon, this massive output is harnessed as a trigger, providing the X-ray flux necessary to ignite the much more powerful fusion stage. In the Teller-Ulam design, this initial fission explosion occurs inside a radiation-reflecting casing called the hohlraum. The fission energy does not immediately escape. It floods the sealed chamber as a blinding wave of high-energy X-rays. These X-rays strike a low-density plastic foam called fog bank that fills the space inside the casing. The radiation instantly vaporizes this foam into a high-pressure plasma. This plasma serves as a buffer, delaying casing expansion and trapping X-rays to build immense pressure. Within this sealed environment, the weapon briefly reaches temperatures and pressures exceeding those found at the center of the sun. Inside this storm of radiation sits the secondary stage, a cylinder of fusion fuel. The trapped X-rays heat the cylinder's heavy outer shell, known as the pusher tamper. This intense heating causes the outer layer of the shell to vaporize and explode outward at supersonic speeds, a process called ablation. Following Newton's third law, this outward explosion creates a massive inward recoil. The fuel column is crushed from all sides by hundreds of millions of atmospheres of pressure. As the isotopes of light hydrogen are forced together, they overcome their natural repulsion and merge. This fusion into heavier helium atoms releases the universe's ultimate power source. In less than a microsecond, ablation and crushing successfully ignites a miniature sun inside the weapon. Back on the macroscopic scale, the weapon's hardware vaporizes into plasma, and the energy breaks away into the atmosphere. This produces a signature double flash. In this test photograph, the initial thermal burst is so intense it turns the surrounding air opaque, briefly blocking its own light. As the shockwave expands and the air cools, the atmosphere becomes transparent again. This releases a second, prolonged flash of light and heat that sears the landscape. This thermal radiation travels at the speed of light, blinding and burning targets miles away before the physical shockwave even begins to travel. The physical blast wave follows, a wall of hyper-compressed air moving at supersonic speeds. The sudden change in air pressure collapses structures and obliterates the terrain. You can see it here. That transparent curve is the shock front, moving ahead of the fireball at over 700 miles per hour. The overpressure from this shock front flattens buildings and turns shattered concrete and glass into deadly, high-velocity projectiles. Above ground, within the primary blast radius, the combination of this thermal pulse and the crushing shockwave makes survival a physical impossibility. Even as the blast wave travels, an invisible hazard remains. Prompt ionizing radiation floods the area, delivering a lethal dose of gamma rays and neutrons in less than a minute. The fireball, now lighter than the air around it, begins to rise rapidly, like a hot air balloon. This creates a powerful vacuum at the surface. That vacuum sucks thousands of tons of dirt, water, and debris into the sky. This material forms the vertical column and the swirling cap of the iconic mushroom cloud as it reaches the stratosphere. The blast is accompanied by an electromagnetic pulse capable of disabling infrastructure. Once the cloud cools, the irradiated debris begins to fall back to Earth. This is fallout, radioactive particles that can contaminate the ground and water supply for decades. The entire sequence, from high explosives to nuclear fusion, must be completed in less time than it takes a nerve impulse to travel. Today, the capability to initiate these thermonuclear chain reactions is wielded by 9 nations. Thousands of intercontinental ballistic missiles are maintained in silos and on mobile launchers. Yet, the same physics, the fission of uranium-235, is also used inside civilian reactors to boil water and generate carbon-free electricity for millions. The atom is a source of concentrated power, but it is morally neutral. Whether we use this knowledge to sustain our civilization or to end it remains a choice we must make every day.